Hi guys, this is Unit 1, Lesson 10. EQ is how can we compare and perform operations on numbers given in both decimal and scientific notation. Today's learning target is I can translate numbers into standard notation form from scientific notation form. The verb in today's learning target is translate. It's going to be very similar to Lesson 9, but we're just doing the opposite. In our brain starter, these two questions can be answered based on the information that we got from the Edpuzzles, but basically we use scientific notation to represent very, very large and very, very small numbers. A real life example in which we can use scientific notation would be possibly an astronaut, a scientist if they want to measure the distance of cells because cells are so small that we cannot even see them. Again, it represents very large or very small numbers. In our mini lesson, we're defining the term standard notation, or in other words, standard form. Standard notation is when a number is written to include all digits. And here in this picture, we see the difference between standard form versus scientific notation form. Standard form is when we have the commas, and scientific notation form is when we have that first number in between 1 and 10, times 10 raised to an exponent. In this part of the mini lesson, we're going to be actually translating into standard notation form from scientific notation form. So what we're going to do is we're going to follow these two steps. We're going to use the exponent power of 10. So in this case, the exponent is 6. And we're going to move that decimal point to the right, however many times the exponent says to. So we're going to have the number 8.25. And since our exponent is 6, we're going to move that decimal to the right. 1, 2, 3, 4, 5, 6 places. All right, and step number 2 tells us to add a 0 in any of these empty spaces that we see. So we see 1, 2, 3, 4 empty spaces. So that means we're going to add 4 zeros to the end of this number. If we include this entire number and write it out nice and neat, we have 8, 2, 5, 1, 2, 3, 4 zeros. And what we do when we are placing our commas is we count from right to left 3 numbers. So we count 1, 2, 3, put a comma. 1, 2, 3, put a comma. So our number is 8,250,000. And we converted it from scientific notation form. All right, we're going to practice one more problem together, and then you're going to give it a shot for the work time. All right, so here we have 3.62. Our exponent is 8, so that means we are moving this decimal point to the right 8 places. 1, 2, 3, 4, 5, 6, 7, 8. We moved it 8 places. There are 6 empty spaces, so we're adding 6 zeros. So we have 3, 6, 2, 1, 2, 3, 4, 5, 6. And we're going to count from right to left every 3 numbers. 1, 2, 3, comma, 1, 2, 3, comma. Our answer is 362 million. For the work time, please copy down these 6 numbers or 6 problems. Let's do number 1 quickly. Since there's no decimal point given to us for number 1, or any whole number that is, we're going to put that decimal all the way at the end. And then we're going to move to the right 5 places. 1, 2, 3, 4, 5. We're adding 1, 2, 3, 4, 5 zeros. So our number becomes 1, 2, 3, comma, 400,000. Copy the rest of these problems, and we are making you complete the rest of these problems in your Cornell notes, as well as completing this closing question. Please make sure that your answer is written very clear for us to see whether the answer choice is A, B, C, or D. Thank you, and have a great day.